Hello, dear students. The next and the most important topic that we are going to see is lattices. So, before moving on to the concept of lattices, we should know certain prerequisites before that. So, we'll first define what is the greatest and least element in a poset. So, let S and less than equal to be an arbitrary poset and A is an element of the base set. Then A is called as the greatest element in the poset if for every element B in the set A is greater than equal to B. And A is called as the least element in the poset if A is less than equal to every other element B in the base set. So here we'll first see an example. We already saw this poset before. Here I'll have to find the greatest and least element. So the least element here is 1. Why? Because every other element is less than or equal to the element 1. Okay, according to the ordering, it is less than equal to. You don't actually have to consider the value or the magnitude of that particular element. You have to consider ordering. Ordering in the sense, the element which is present lower has less magnitude than elements present above it according to the poset. So here the least element is 1. What about greatest element? There is no greatest element. Why? Because there are two elements at the top, 8 and 12. But can two elements be greatest at the same time? No. There is only one least element and one greatest element. And 8 and 12, they are incomparable according to this poset. Hence, we cannot determine which element is prior to which element because they are incomparable and present at same level. Hence, there is no greatest element for this poset. Similarly, the second poset that we saw here, you can clearly see that the least element is the null set and the greatest element is the base set itself. Why? Because phi is less than equal to every other element in the poset and ABC is greater than or equal to every other element in the set. So that is why these are the greatest and least element respectively. Now, moving on to the next concept, that is upper bound and lower bound. So sometimes it's possible to find an element that is greater than or equal to all the elements in a subset of a poset. So here we are considering a subset of the poset. And for that subset, we are calculating greater elements and least elements. So here, if U is an element of the set S such that U is greater than or equal to all elements of a subset A, then U is called an upper bound of the subset A. Likewise, there may be an element which is less than or equal to all the elements in the subset A. So here, if L is an element of the set S such that L is less than equal to A for all elements of the subset A, then L is called lower bound of. So you might be confused with all these definitions. So let's consider an example. Here, this is the given poset, and you have to find the lower and upper bounds of subsets ABC, JH, and ACDF. So we'll consider them one by one. So you'll be given subset or a part of the actual poset. And for that, you have to find the upper bound and lower bound. So here I'm considering the subset ABC. So here these are the elements A, B, C. For that, I have to find the upper bound. Upper bound is nothing but any element in the poset that is related to all the elements in the set and it is greater than or equal to each element in the set. So I can find such elements. So one is E because it is greater than all A, B, C. Then F, then there is J, and there is H. Why haven't I taken G and D? G and D is not taken because even though from A and from B I can reach G and D, but can I reach D or G from C? No, because C is not connected to either G or D. That means they are not related. Hence, G and D are not the upper bounds. Okay. So here the same thing is given here. E, F, J, and H. Then the lower bound of these three A, B, C is any element that is less than equal to all the elements in the set. So which is such element? It is A. Why? Because it is less than equal to all A, B, and C. Similarly, for other sets, I can do the same for other sets. Next set is JH. So J and H is my set. So upper bound. So can I find any element that is greater than or equal to both these elements? There is no element that is greater than JH. Is any element equal to JH? No. Why? Because they are also incomparable. So there are no upper bounds of J and H. But I can find the lower bounds. So the lower bounds are A, B, C, D, E, and F. Next set is ACDF. You can verify it yourself and you will get that its upper bound is F, H, and J, and lower bound is E. So now we'll move on to the next concept of least upper bound and greatest lower bound. So the element X is called as least upper bound of the subset A if X is an upper bound that is less than every other upper bound. And element X is called as greatest lower bound if X is a lower bound that is greater than every other lower bound. Okay. So here even among the lower bounds and upper bounds, I'll have to find the least and the greatest. So here this question is given to us to find the greatest lower bound and least upper bound of this subset BDG. So which is this subset B, D, and G? This is the subset. So what are the upper bounds of BDG? It is G and H. Which is the upper bound of BDG? G and H. Amongst them, which is the least according to the ordering? G is lower than H. That's why G is the least upper bound. And what is the lower bound of BDG? It is B and A. So among them, which is the greatest? According to the ordering, B comes above A. So that is the greatest lower bound of this subset. So you can consider any subset and try to find its least upper bound and greatest lower bound. Now, moving on to the definition of lattices. A lattice is a partially ordered set in which every pair of elements, now the subset will be a pair. Here the subset is a pair of any two elements in the poset. And every pair has both a least upper bound and greatest lower bound. So this pair should have least upper bound and greatest lower bound, both. If every pair of elements satisfies this property, then it is a lattice. That poset is a lattice. So here you have to determine whether the poset represented by these figures are lattices or not. Pause this video and try to find the answer. So I hope you might have tried finding the answers. So here, the first poset, that is A, first Hasse diagram, is a lattice. Why? Because every pair of elements has both a least upper bound and greatest lower bound. So consider pair C, D. This is my subset. So which are its upper bound? Upper bounds are E, F. And among them, which is the least? Least is E. So this is least upper bound. And which are the lower bounds of CD? They are B and A. So among them, which is the greatest? B is the greatest. So this is the greatest lower bound. So yes, this pair has both. Now I'll consider any other pair. Let's say I considered EF. Which is the upper bound of EF? It is F. And it is the least upper bound. Which are the lower bounds of E and F? It is C, D, B, and A. So among them, which is the greatest? Even E is the lower bound of E and F. So among them, which is the greatest? E is the greatest. So E is your greatest lower bound. So likewise, you consider any pair of elements, they will have both. If I consider B and D, this is the least upper bound. This is the greatest lower bound. Okay. So you consider any two pairs, they will have both. Now, second example, B. This is not a poset. Why? Because if you consider these two elements B, C, they have a least upper bound, that is A. They have a greatest lower bound, that is A. But can you determine the least upper bound? They have upper bounds. Upper bounds are D, E, and F. These are upper bounds. But among them, which is the least? Can you determine a specific ordering between D and E? No. Why? Because they are incomparable. You cannot determine specific ordering. इन दोनों में से सबसे least कौन सा है आप ये determine नहीं कर पाओगे according to the ordering. So that is why we cannot find a least upper bound for even if you cannot find it for one pair, the entire poset is not a lattice. So B is not a lattice, A is a lattice. Read the note that is given at the bottom. You will understand more clearly why B is not a poset.